This is something that I found from Isaac Newton. Truth is ever to be found in simplicity and not in the multiplicity and confusion of things. That's why physics concept constructions is very important before you apply the concept to any calculation in this world. Assalamualaikum warahmatullahi wabarakatuh and have a very good day. So today we will continue our lesson to subtopic 1.1 resultant force. Right. So today we will learn number 1 types of forces and free body diagram, and then resultant force. Next, we will apply Newton's second law, and last but not least, problem solving. So how many forces did you know? We know about frictional force, right? So what is the definition of frictional force? Frictional force is a type of force which always opposes the direction of motion of an object. For example, here we have one box. Then we can see a man is pulling the box, and the direction of motion of an object is to the left. So the frictional force opposes the motion and its direction is to the right. Next, gravitational force. So what is gravitational force? Gravitational force is a force which always directed towards the center of gravity. Okay, now we have tension. T. Tension is a force which is exerted by a rope, cable, or chain. Next, normal force. Okay, normal force is a type of force which is perpendicular to the surface of an object. Alright, next we go to number 2, resultant force. So what is resultant force? When two forces of the same magnitude acting in opposite direction are applied on a stationary object, the object remains at rest. In the diagram here, we have a hanging ceiling fan, and then we have a flower vase on the table. But can you see the magnitude, the direction in this diagram? I can be sure you cannot see any forces, right? That is why we need to learn free body diagram. So what is free body diagram? Free body diagram is a diagram which is used to show the relative magnitude and direction of forces acted on an object. For our example here, the ceiling fan, so we have two forces acted on the ceiling fan, which is weight. It always directed towards the center of gravity, and the second force is the tension, which is the force exerted by the cable. In this situation, at least, alright, the tension must be equal to the weight so that the ceiling will be at rest. Okay, now we continue to the vase on the table. So there are two forces acted on the vase. The first one is, yes, it is gravitational force or weight acted downwards towards the gravity, and the normal force. So for example, an aeroplane has same magnitude of forces in all directions. Which direction does the aeroplane moves? For this scenario, let's discuss the forces in terms of y-axis and x-axis. So what are the forces in y-axis? So we can see that there are two forces in y-axis, which is towards upwards is lift and downward towards the gravity is weight. Okay, those are two. And how about the forces acted at the x-axis? So there are two types, which is thrust, okay, and drag or frictional force. Alright, now question asks, the aeroplane has same magnitude of forces in direction. So this means that weight equal to lift, drag equal to thrust. So which direction does the aeroplane moves? When drag equal to thrust, lift equal to weight, so there is no resultant force, or force equal to 0 Newton. Alright, I forgot to write Newton there. So I will put here 0 Newton. Alright. The aeroplane moves in constant velocity. So the velocity will be constant and the direction will be to the right, to the thrust. Assuming that there are two opposing forces which have different magnitudes, the object will move in the direction of the larger force. Alright, so let's say we have a car here and then the car, okay, so for the car, we will discuss the forces which acted at the x-axis, right? So what are the forces which acted on the car? They are drag and thrust. So if thrust is higher than drag, obviously that the car will move to the right. Thus, we say that there is resultant force because the car moved to the direction of the larger force. There are two forces and one force is higher than another. So there is resultant force. So this is the example when there is resultant force. For example, there is a plane and it does not stay in equilibrium force. So it is unbalanced force. For example, okay, we know that the aeroplane, they have four forces acted on it. The first one is thrust to the left for this example and drag to the right, lift upward and weight downward towards the gravity. Alright, for the flight condition, if lift is higher than weight, so the plane rises. If weight higher than the lift, so the plane probably will be descending. And what happens when drag is higher than thrust? So the plane slows down. If thrust is higher than the drag, so the plane accelerates. So that is the explanation of the unbalanced forces acted on an aeroplane. Next, how to determine a resultant force. When we discuss how, so the answer is we want to know the method. How is the question and the explanation is the method. What are the sequence to solve the problem to determine the resultant force? So a resultant force is a vector sum. So this is very crucial for you to remember that vector is a physics quantity which consists of magnitude and direction. So we must determine the magnitude and direction of the forces to determine a resultant force. So we have situation number 1. There are two forces acting on an object in the same direction. So we have an object here and there are two forces acting on it to the right. Okay. Now, the first force is 3 Newton and second force is 4 Newton. To describe the resultant force acted on the object, we must mention about its magnitude, its direction, and the final answer is the resultant force. So, magnitude is 3 plus 4. So, it is positive because from the graph, we know that x to the right is positive, right? So, magnitude is 7 Newton, direction to the right. So the resultant force is 7 Newton to the right. For the second situation, there are two forces acting on an object in the opposite direction. So remember again, force or forces to the right is in a positive symbol and Forces of force to the left is negative symbol. 5 minus 3. For the second method, we apply trigonometry, and please remember the Sohcahtoa. I don't have to remind you of this, right? So we have the angle here, okay, from the head of the first force to the head of the second force. Okay, you make a line, and then you find the theta here, angle. So we get the angle will be 36.9. For cos 36.9, which is adjacent 8 Newton divided by resultant force, you will get the resultant force as 10.00 Newton. And if you try and error to use sine 36.9, so sine is opposite 6 Newton divided by the hypotenuse or resultant force, so you will get 99.99 Newton. And for the third method, you can draw in a scale diagram. You might use a graph paper, and then you measure 6 centimeter, okay, to the y-axis and 8 centimeter to the x-axis, and you use the ruler and measure the resultant force, which is 10 centimeters. So we have 3 methods to determine the resultant force. How about forces which are not perpendicular to each other? So there are 2 ways to solve this problem. First, use the method of triangle of forces, and second, you can use parallelogram of forces method. To apply this method, you have to have this measuring instrument, which is a ruler, a protractor, and a compasses. So we have a very general solution here. So you have the first force, we have a second force. The second force is from the head, all right, of the first force. And then when you have drawn the first force and the second force, so the resultant force is from the tail of the first force to the head of the second force. Precisely, I will explain to you on how to solve this problem. Right, for example, we have one object here, the pink colored object. So we have 2 forces acted on this object, which is 600 Newton and 700 Newton at the angle of 65 degree. So we can assume that the resultant force will be about more to 700 Newton because it has greater force. Now, what should we do? So we must choose a suitable scale and use ruler and protractor. So we decide the scale, which is 1 centimeter equal to 100 Newton. So we have 6 centimeter here, okay, to represent 600 Newton. And then, okay, we use the protractor and measure 65 degree. And from that, we measure by using ruler 7 centimeter to represent 700 Newton. To find the resultant force F, it starts from the tail of first force, the F1, and it ends at the F2 head. Okay, the head of F2. Now, you measure the length of the F, resultant force, and then you substitute by the scale. And don't forget the angle, which is the direction of the F. Very general solution here. We have first force, which is U, and then we have second force, which is V. And then we will use parallelogram to determine the resultant force. So this is the example of problem solving Okay, we have two forces acted on an object. Okay, one is 500 Newton, the other one is 800 Newton. So we must choose a scale and use ruler and compasses. Okay, our scale is 1 centimeter to 100 Newton. Then, with the aid of compasses, complete the parallelogram. So you can see that there are blue dotted lines here, which is as same length as the F1, okay, and it is parallel to F1. And F2 we have 5 centimeter, and we have another blue dotted line which is also the same length as the F2, which is 5 centimeter. Now, can you determine the resultant force? Yes. You can determine the resultant force by drawing and measure the diagonal line F, and don't forget to measure the theta. Next, applying Newton's second law. So Newton's second law is regarding the F equal to ma. So mass times acceleration is the force exerted on an object. So we have an object in a stationary state. So we have a stationary car, means the car is at rest, it is not moving. So what are the forces acted on the car? Okay, now the velocity is 0, acceleration equal to 0, so F equal to ma. When A equal to 0, so resultant force equal to 0. So for the object which is in stationary state, it does not have resultant force. For an object moving with a uniform velocity, so now we can consider the forces acted on the car in x-axis, which is thrust to the right, if you refer to this diagram, and frictional force to the left. When the velocity is constant, what happened to A, which is acceleration? Acceleration equal to 0, right? So when we apply the Newton's second law, F equal to ma, so there is no resultant force. And lastly, for the object moving with a uniform acceleration, so acceleration, it has some values. Let's say x meter per second per second. So there is a resultant force. The resultant force is not 0 Newton. Last but not least, we come to the problem solving. So I have choose one problem. We have one trolley here and a load. And in between the trolley and the load, there is one pulley. The pulley connected the trolley to the load, and the load will accelerate downwards due to gravitational force. At the same time, the trolley also accelerates at the same acceleration with the load. That is the scenario. Sketch the free body diagram. B. Compare the weight of the trolley W with the normal reaction. C. Calculate the resultant force acted on the trolley. E. Find the mass of the load here. In this question, they did not mention about the mass of the load. The mass of the trolley is 1.2 kilogram, and both objects accelerate at the same acceleration, which is 4 meters per second per second. And one more information, the frictional force for the trolley is 6 Newton. So let's see how we will solve this problem. Draw the free body diagram. We must particularly consider the forces acted on the trolley and then the forces that acted on the mass, the load. Okay, first of all, what are the forces that acted on the trolley? So we must consider the y and x axis. So y axis, there are two forces acted on the trolley, which is W weight and normal force. And the forces that acted on the x axis is T, which is tension of the rope or cable, and frictional force, which is opposes the motion of the trolley. As mentioned before, it is 6 Newton, right? Okay, now those are the forces acted on the trolley. How about the forces acted on the load? So there are two forces that we discussed. We only discussed the forces acted on the y-axis because there is no force acted on the x-axis. So the forces are tension and also W by, we name the W as B for us to be easier to calculate later, because W is the weight of the trolley and B is the weight for the load. Question B. What is the weight of the trolley? So, to compare the weight of the trolley and the normal reaction, those two forces are the same. They acted at the different direction but at the same magnitude. What is the resultant force acted on the trolley? Now remember, resultant force is the application of Newton's second law, which is force F equal to ma. Given that the mass of the trolley is 1.2 kilogram and the acceleration is 4.0 meter per second, so the answer will be 4.8 Newton. Find the tension in the string pulling the trolley. Consider the forces acted on the x-axis. There are only two forces, which is tension and frictional force. And then we know from the question that the trolley accelerates to the right, which means that tension is higher than the frictional. So Mr. Snail said that forces acted on the trolley at the x-axis are tension and frictional force, and then the trolley is accelerating. Thus, resultant force F equal to T, because T is higher, minus frictional force. Thus, to find the tension is equal to force F equal to ma plus frictional force, which is 6 Newton. So the answer will be 10.4 Newton. Find the mass of the load. So we need to apply the Newton's second law, which is F equal to ma. M is the mass of the load and acceleration is as the same as the acceleration of the trolley. So it is 4 meter per second. So we have the first equation, which is F equal to F4m, and then we have the second equation B, which is W equal to mg. So we do not know what is the mass of the load, and times 9.81, which is the gravitational, m equal to 1.86 kilogram. Remember, concept construction first. Therefore, see you another day, another time, another chapter. Bye. Assalamualaikum.